Now we're going to use the inverse property to solve some logarithmic equations. So on the example 1, you'll notice that I have a log with a numerical base. On the right-hand side, or example 2, you'll notice that I have an equation involving the natural log. So the process is going to be a little bit different. But here, we basically want to identify where our log base is on one side, and we need to get rid of these other numbers first. So the first thing we're going to do is subtract 3 from both sides. So that's going to leave me with 2 log base 5 of negative 2x equal to 6. And then I need to get rid of this 2 that's being multiplied, so I'll go ahead and undo that by division on both sides. So I'm left with log base 5 of negative 2x is equal to 3. And then the inverse property says that when I have a log of a numerical base, I can rewrite this in exponential form. So my base of 5 is going to be raised to my exponent of 3, and it's going to be equal to this stuff on the inside. So 5 to the third is equal to negative 2x. I'm going to go ahead and evaluate 5 to the third, which is 125, equal to negative 2x. And then I can go ahead and solve for x by dividing each side by negative 2. So that tells me that my x value could be negative 62.5. And I want to also make sure that I'm going back and checking in my original equation to make sure that it's not giving me a negative. So this is a valid solution. So here's my check. 3 plus 2 log base 5 of negative 2 times negative 62.5 is equal to 9. And I'm just going to simplify on the inside here just to make sure I'm not getting a negative. So 3 plus 2 log base 5, negative 2 times negative 62.5 is positive 125 equal to 9. So that is a positive solution, or a positive inside the parentheses there. So x is equal to negative 62.5 does work here. My other type of inverse property equation that I could run into is something with a natural log. And you'll notice that there's no number here. But remember that the base of a natural log equation is always e. So if you need to write in that e, go ahead and do that. The natural log stuff is by itself on one side already, so I don't need to undo any numbers like I did over here. So I can go straight to exponential form here. So I'm going to take my base of e, raise it to its exponent of 3, and set it equal to this stuff. So e to the third is equal to 8x minus 40, and then I can start my solving process to get the x by itself. First thing I'm going to do is use my calculator to evaluate e to the third. That's about 20.086. That's equal to 8x minus 40. And I can go ahead and solve for x. So I'll get rid of that negative 40 by adding 40 to both sides. So that's going to give me 60.086 equal to 8x. And then I can go ahead and divide each side by 8 here. So our x value should be about 7.511. And I'm just going to go ahead again and check my solution to make sure it's not giving me any sort of negatives on the inside of the parentheses. So ln of 8 times 7.511 minus 40 is equal to 3. I'm going to clean that up a little bit. Grab my calculator here. So 8 times 7.511 is about 60.088 minus 40 is equal to 3. And just do one more step. So again, simplify on the inside here. So that'll be 20.088 equal to 3. Gives me a positive solution. X is equal to 7.511. Does work.